Dear students, welcome to my 5th class on Module 1, Laplace Transforms. In this lecture video, we're going to discuss about inverse Laplace transforms and problems on inverse Laplace transforms. Okay, first we will learn what is inverse Laplace transforms. As we know that in the Laplace transform, we'll be converting the time valued function in terms of frequency by using the operator Laplace transform L. But in the case of inverse Laplace transform, we'll be converting the frequency into time with the help of the Laplace inverse operator. That is, if capital F is the Laplace transform of the function f of t, that is, if Laplace transform of f of t is equal to f of s, then we say that Laplace inverse of f of s will be equal to f of t. The important property of inverse Laplace transform is the linearity property. So it is given by Laplace inverse of a into f of s plus b into g of s will be equal to a into Laplace inverse of f of s plus b into Laplace inverse of g of x. So this property will be using in all the problems to solve the problems in the inverse Laplace transforms. Example number 1. Find the inverse Laplace transform of 3s cube minus 5s square minus 2 whole divided by s power 4. So now here, how to convert this s in terms of t, in the sense we have to use some standard inverse Laplace transform formula. That is, as you know that Laplace transform of 1 will be equal to what? It is 1 by s. So here similarly, the Laplace inverse of 1 by s will be equal to 1. In the same way, Laplace transform of e power at, we got 1 by s minus a. So now the Laplace inverse of 1 by s minus a will be e power at. Also, the Laplace transform of e power minus at is 1 by s plus a. But Laplace inverse of 1 by s plus a is e power minus at. So in the same way, the Laplace inverse of 1 by s power n will be t power n minus 1 divided by n minus 1 factorial. So this formula will be applying to simplify this s cube, s square and divided by s power 4 also. So now I'll be taking f of s is equal to this equation. So they have given that f of s is equal to 3s cube minus 5s square minus 2 whole divided by s power 4. So now I am going to divide the each term of this s power 4 with s cube, s square and 2. So we'll see how we'll get the equation. Therefore, the Laplace inverse of f of s will be equal to Laplace inverse of 3s cube minus 5s square minus 2 whole divided by s power 4, or by applying this 1 by s power 4 for each term. So we'll be getting Laplace inverse of s cube by s power 4 minus 5 into s square by s power 4 minus 2 divided by s power 4. So we got the Laplace inverse of 3 by s minus 5 by s square minus 2 by s power 4. So now to expand this one, I am going to apply the linearity property. So by applying linearity property, so we can write that Laplace inverse of f of s will be equal to 3 times of Laplace inverse of 1 by s minus 5 into Laplace inverse of 1 by s square minus 2 into Laplace inverse of 1 by s power 4. So now to simplify this one, that Laplace inverse of 1 by s will be 1. So that formula I am going to replace here. So now to simplify this Laplace inverse of 1 by s square, I am going to use Laplace inverse of 1 by s power n formula. It is given by t power n minus 1 divided by n factorial. So that formula I will be applying here. So what I will get? So it will become 5, I will keep as it is. So t power 2 minus 1 by 2 factorial, it will become t by 2 factorial. Same thing here also. It will become minus 2 times of 2 into t cube by 3 factorial. So the required answer will be 3 minus 5t by 2 factorial means 2 minus 2t by 6 is the required solution. Example number 2. Find the inverse Laplace transform of 5s by s square plus 36. Okay, to simplify this one, we have to use cos at formula. Okay, as we know that Laplace transform of cos at is what? S by s square plus a square. Similarly, Laplace inverse of s by s square plus a square will be equal to cos 80. So in this equation, if you apply Laplace inverse on both the sides, so I'll get Laplace inverse of s by s square plus a square is equal to cos 80. The same formula I'm going to use here also. So now Laplace inverse of 5s by s square plus 36 will be equal to 5 times of Laplace inverse of s by s square plus 6 square we can write. By applying the linearity property, the constant phi I took outside. So the constant phi I'll keep as it is. So this will be equal to what? Cos 60 according to this formula. So therefore, the Laplace inverse of 5s by s square plus 36 is 5 into cos 60. Next problem, find the inverse Laplace transform of s by s square plus 4s plus 13. So now I am going to solve this problem with the concept of completing square. So now first consider Laplace inverse of 5 by s square plus 4s plus 13. So I am going to rewrite this equation as Laplace inverse of 5 divided by s plus 2 whole square plus 9. So just I am writing this s square plus 4s plus 13 as s square plus s plus 2 whole square plus 9. So like after expanding this s plus 2 whole square, we will be getting s square plus 4s plus 4. So 4 plus 9 will be 13 here. The same thing is here. So now I am going to apply Laplace inverse for this one. So we will be getting 5 into e power minus 2t into Laplace inverse of 1 by s square plus 30 square. So 3 square. So this is because of shifting property. And we got finally 5 into e power minus 2t. This is for sine 3t. We got sine 3t here. Example number 4. Find the inverse Laplace transform of 1 by s into s square plus a square. So now I am going to simplify this one by applying inverse Laplace transform. So what I will do means here I am going to choose the function f of s as only 1 by s square plus a square. So for that function I am going to apply the inverse Laplace transform. So therefore Laplace inverse of f of s will be equal to Laplace inverse of 1 by s square plus a square. So we got f of t is equal to 1 by a into sine a t. So now to solve this Laplace inverse of 1 by s into s square plus a square, I am going to use this property. That is Laplace inverse of f of s by s will be equal to integral 0 to t f of t dt. So in the place of f of t, I am going to replace 1 by a sine t. So like after solving sine t, so we'll be getting the equation like 1 by a square into 1 minus cos t with the limit 0 to t. After applying this, we got this function. Okay, in the next lecture video, we'll be discussing few more problems on the inverse Laplace transform only. Thank you.